Welcome to BNF Interpreter, a project by Blake Marshall, Brandon Robinson, Holden Jacob Sellers, and Rolando Yax. This program was developed as the culminating project for a course on programming languages, CS 460, at Sonoma State University. This project presents an interpreter designed to process and execute code written in Bacchus-Nor form. Our project interprets the input in BNF, analyzes its structure and logic, and executes the corresponding computations to generate the desired output. This project exemplifies advanced concepts in parsing, syntax analysis, data structures, and interpreter design. The interpreter was constructed through a modular design, which was comprised of several key components that work in sequence to process the input. These components include comment removal, tokenization, recursive descent parsing, symbol table generation, abstract syntax tree generation, and finally, the full interpreter. Beginning with comment removal, this component aims to strip code of all comments. While this component does leave the original file intact, it makes a copy of the code and works to remove comments on this duplicate. Since comments are for humans and not for machines, these comments are unnecessary for computations, and keeping them would require additional logic and later steps. Let's see an example of this component in action. Looking at this file, we can see a combination of standard comments as well as block-style comments. After running the comment removal component, we can see that the logic of the file remains the same, but we no longer have comments. Spacing and line numbering remains the same so that correct error messages can be given to the user if they are to give the interpreter bad input. Moving on to our second component, tokenization aims to break programs down into smaller pieces that can be processed individually. Take this file, for example. After first running it through comment removal and then tokenization, we're left with output that consists of each individual portion of our code. These are called tokens, and while they aren't necessarily useful on their own, we will see how they contribute in just a moment. Similar to humans turning words into sentences, our interpreter turns tokens into statements and declarations. Using the tokens we obtained in the last component, step 3 aims to build a concrete syntax tree. This concrete syntax tree, or CST, is used to give the interpreter a preliminary path to follow during execution. Component 4 involves creating a symbol table. To put it simply, a symbol table will consist of all relevant variables that will be used in a program's execution, along with their values, scope, and other valuable information. For example, if we feed in this file, we obtain a symbol table that looks like this. This symbol table will be continuously updated with relevant values as the interpreter runs, to ensure that variables remain correct throughout execution. Earlier, we built a concrete syntax tree that would give the interpreter a preliminary path of execution. In this step, we improve upon this and turn it into an abstract syntax tree. As you can see, the beginning of each line now has descriptors like declaration and assignment that make it easy for the interpreter to understand how to process the remaining code on that specific line. The abstract syntax tree and symbol table are arguably the most important components for successful execution of the interpreter. In the final step, we introduce additional logic to complete the interpreter. While there is far too much to describe in this video, this step uses a combination of all 5 other components to assemble a fully functional interpreter. For example, if we run this test file, we receive this output. Or, if we instead run this test file, we receive this output. As you can see, we have an interpreter that really works. If you'd like to try our interpreter, it's compatible with macOS, Linux, and Windows, and is available on our GitHub. All 6 components are testable individually, and our test files are available as well. Thank you for taking the time to hear more about our interpreter. We hope you've enjoyed.